if you're going to optimize for performance, saying, why can't we be at 1 millisecond? Or why can't we be at 10 milliseconds and start from there? Instead of sort of saying, hey, let's try to decrease latencies by 50% or 25%. Let's just start from what is the conceptually fastest thing that we could do. And that's actually how Amazon was created.
Amazon's principal engineering level is unique in many ways across big tech. Steve Huynh was a software engineer at Amazon for 17 years and worked as the last 4 years as a principal engineer. Today, we talk about the ins and outs of this role, including why being promoted from senior to principal is so hard, even though Amazon usually has hundreds of principal engineering openings and thousands of seniors trying to get into these positions. The Amazon principal engineering community, the in-person events, the Slack group, and the Principles of Amazon internal presentation series. Engineering concepts at Amazon are on reliability, such as brownouts and COE, correction of errors, and many more topics. If you're interested in understanding one of the hardest engineering levels to get into across big tech, together with stories of how Steve thrived in this position, this episode is for you. Subscribing on YouTube and on your favorite podcast player greatly helps more people discover this show. If you enjoy it, thanks for doing so. So Steve, welcome to the podcast.
Thanks for having me.
How long were you at Amazon? 17 years?
Yeah, I was there for 17 and a half years. And yeah, I just quit last year. So I've been basically a year doing other things now.
And what were the things that you worked on while you were there?
You know, people always talk about my long tenure there, but, I feel like I've had like 5 or 6 jobs over that time period. I started off on, a project called Search Inside the Book. I worked on the first Kindle launch.
Wow.
I worked on the precursor to Prime Video. I sort of like worked there at the beginning part of my career, and then I sort of ended my career there for the last 5 years of my time there. I worked in payments. I worked in Amazon Local, which was sort of our Groupon project when that type of business was looking like it was going to take over. I worked on Amazon Restaurants. I worked on Amazon Tickets, which is our Ticketmaster clone. And then my last 5 years was working on live sports streaming on Prime Video.
If you want to build a great product, you have to ship quickly. But how do you know what works? More importantly, how do you avoid shipping things that don't work? The answer? Statsig. Statsig is a unified platform for flags, analytics, experiments, and more, combining 5+ products into a single platform with a unified set of data. Here's how it works. First, Statsig helps you ship a feature via feature flag or config. Then, it measures how it's working, from alerts on errors, to replays of people using that feature, to measurement of top-line impact. Then you get your analytics, user account metrics, and dashboards to track your progress over time, all linked to the stuff you ship. Even better, Statsig is incredibly affordable, with the super generous free tier, a starter program with $50,000 of free credits, and custom plans to help you consolidate your existing spend on flags, analytics, or A/B testing tools. To get started, go to statsig.com/pragmatic. That is statsig.com/pragmatic. Happy building! This episode is brought to you by Graphite, the developer productivity platform that helps developers create, review, and merge smaller code changes, stay unblocked, and ship faster. Code review is a huge time sink for engineering teams. Most developers spend about a day per week or more reviewing code or blocked waiting for a review. It doesn't have to be this way. Graphite brings stack pull requests, the workflow at the heart of the best-in-class internal code review tools at companies like Meta and Google, to every software company on GitHub. Graphite also leverages high-signal, code-base-aware AI to give developers immediate actionable feedback on their pull requests, allowing teams to cut down on review cycles. Tens of thousands of developers at top companies like Asana, Ramp, Tecton, and Vercel rely on Graphite every day. Start stacking with Graphite today for free and reduce your time to merge from days to hours. Get started at gt.dev/pragmatic. That is G for Graphite, T for technology.dev/pragmatic.
Oh, so that's a lot of different teams. Was it like, how did you work on so many teams? Is it just like there's a lot of internal transfers? Did you get bored? Was it just you followed your manager? How does it work inside Amazon? Because when people think about companies, people who have not worked on Amazon, they would kind of assume you go, you work there, you're on a team for 4, 5, 6 years. Clearly not the case.
It depends a little bit on like corporate policy and then where you are with your career. I started as a support engineer, so sort of like operationally focused person. And then, I was basically like, I want to be a software developer. And so, I think getting into the company was pretty difficult, but once I was there, sort of set that target and changed roles. And when I changed the role, it was a natural time to move to another team. There's also some internal policy. So basically at Amazon, it used to be that you had to stay on a team for at least a year before you transferred. And if you wanted to transfer, like a senior manager or director or whoever up top could block your transfer. And what that ended up meaning was that like certain teams that were just terrible to work on, those teams actually had more than 100% attrition over the course of a year because you measured attrition with a year-long time unit. Amazon did something actually smart at the corporate level. They basically said, okay, well, you have freedom of movement now. This sort of happened, I don't know, probably like 13 years ago. And so they said, you have freedom of movement now. A VP or a director can't block you. They can say, okay, well, we need another month to get like a transition plan going. But essentially you have freedom of movement as long as you're not on a performance improvement plan, which meant that certain teams were sources of high quality engineering talent and certain teams were sinks of high quality engineering talent. And it sort of created an internal marketplace for different roles. Now, what that ended up meaning was that certain teams, they basically didn't want you to know what the policy was. They wanted you to sort of think that you were kind of stuck. But, despite that sort of like local gamesmanship that was going on.
Yeah, like basically some managers didn't want their best people to leave, right?
Exactly.
So let's just say it how it is.
But ultimately, I think it's a great strategy because it put if there was a team that was difficult to staff, the problem was on the management. It wasn't something that had to be bared by or born from the employee themselves. And so, getting back to my own career journey, at a very large company like Amazon, there are so many awesome things that are going on. And, I decided to just kind of go where my curiosity took me. Now, there were some times where, there were reorgs or, a line of business got spun down. But ultimately, I think freedom of movement was one of the smartest things that Amazon did.
And I think this is something that people don't really appreciate about some large companies. So, not all companies are like Amazon, and every company changes, right? Like today, I'm assuming it will be hard to move as many teams within Amazon, depending on where you are. If you're in a satellite office where there's 2 teams, you can probably move on to the other team at max. But I think this is one of the underrated things of large companies. Like once you are in, it's almost always easier to get that job at another team from the inside.
Yes.
Especially because you can talk to them. I talked with the Reddit mobile team and I asked like, oh, how can you become a platform engineer on the mobile team? And they said like, well, most of our hires have been internal. They just helped us out on hackathons. They come around, they commit stuff. We know them. It's a low risk hire. I think it's just nice to remember that when you think of like a big company like Amazon or Meta or Microsoft, it's just so many small teams. And once you're in, you actually have almost priority access to those teams if you play your cards right.
Absolutely. And, you might interview for that team, but it's such lower stakes than an external interview. And, just all things being equal, would you rather take somebody that's, internal and knows the culture, they know how software is developed within a particular context, or somebody that's just as good, but doesn't, hasn't been onboarded? And I think ultimately you're going to pick the person that's internal, all things being equal.
Yeah, it's just kind of like business rationality for the most part. So one thing about Amazon and about large companies like Amazon is people talk about externally about the scale. And it's hard to imagine, but can you give us a sense of the scale that you've seen or like some tough engineering challenges that you worked on that would have been just really hard to work at a smaller startup?
Yeah, I think that's the thing that you will not see at most other places is the scale of things. I'll give you a couple of examples. So, Prime is the exclusive club that everybody is a member of.
Yeah.
And, in the US, the shipping benefit is probably, the most popular. But globally, Prime Video is, it's the thing that people use the most with their subscription. And so if you think about, our service-oriented architecture and, just loading up the app, the gateway page is the place where all of our requests come in, right? And so it's just like Netflix. It's this infinite scroll of carousels.
So the gateway page, is it the Amazon Prime landing page?
Yeah, it's the landing page there. And so you're like, oh, okay, cool. If let's say 90, 95, 99% of all of your requests are coming from that page, and that page needs to be personalized, and you have a service-oriented architecture with a bunch of microservices, one request to that page turns into, let's just say, hundreds of downstream requests to different services. It might even be more than that. It's actually kind of hard to count.
Yeah, and is this page, right? Like all the stuff flowing, all personalized stuff.
So that's the retail one, but I was talking about the Prime Video one.
The Prime Video.
But essentially it's the same thing.
Yeah.
And so, same thing for the retail website as well. And so if you have one request sort of spidering out into, 2 orders of magnitude more requests internally, you start to see like really, really large scale for these microservices. So a microservice will have like a reverse proxy or a load balancer in front of it. And you are sort of unironically talking about things like tens of thousands of requests per second or hundreds of thousands of requests per second coming into your service.
So like the services that are like behind, like there's the Prime, there's all the things loading, they're spidering out, like making, to render that one recommendation, for example, for, I don't know, the video that you would like, it'll make a lot of requests to different services. And then so when you're operating a smaller service inside of Amazon, suddenly you're going to be hit with what you just said, 10K, 100K requests per second, that kind of scale.
Exactly. And you will essentially be DDoSing yourself. You're just like, oh, okay, cool. Let's change a caching configuration on some item details. And turns out you've just browned out like a critical service, right?
What does brown down mean?
Oh, sorry, I'm using some jargon. So if you want to talk about availability, if you suppose you are DDoSing a service or sending a lot of requests over to them, you can just take them down. That would be like a blackout.
Yeah.
And so like you send a request, you can't establish a connection, it immediately comes back. But there's a type of outage where they brown out. So basically, they're reachable. They might accept a connection, but they'll essentially time out, or or they might return partial results or bad results, or the only thing that they do return is a 500 for some percentage or proportion of the
after we waited a bunch of time for that. Yeah,
and so. Now we start talking about like availability and resilience in the face of like all of these this DDoSing that you're doing to yourself. And so the thing on top of scale that is going to really complicate things is your dependency chain, right? And so, your service is a dependency of some of the process that's going on. It depends on, maybe AWS. It may depend on another service. How do you make sure that if suppose there's a failure for a primary dependency and that dependency comes back up, how do you make sure you don't just like inundate it with a bunch of requests as it's trying to recover?
Yeah.
And so you have all of these sort of like odd dynamics that occur. I used a brownout as something that is a perennial problem that we have, right? Where there's maybe a dependency on a base service like S3 or DynamoDB or whatever it is. There might, be some increased latency that may cause a chain reaction of a dependency going down. And then one of these sort of middle tier services would brown out. So what are you're an owner of the services for your team. And so then it's like, okay, what do we do in those situations? How do we know that they're browning out? What do we do in the face of, a dependency outage? And then critically, if there is an outage and then the service comes back up, how do we make sure that we give it enough space so that it can breathe so that, as they're trying to recover from some sort of outage, we don't just take them down immediately again.
And I guess for like most of us who are not working right now on these services, like these sound pretty cool in theory, but you're saying this was actually like this is not theory. This actually was like, this service is going down. We are literally having 100K requests per second, and we're like pushing that on to like other 3 services with the same, because we need to invoke 3 other services. One of them has browned out. Yes. What do we do now? How do we fix it?
Yeah, and I think for certain other large tech companies, you can do best effort. right? Which is basically like, hey, we're temporarily down, but you can you have some sort of degraded service that makes sense. But if you're on, say, a website that does purchases, now we're talking about transactions.
Yeah.
Or if you're in the Prime Video, like live video streaming use case, now we're talking about a football game that you're unable to see. And then when we recover, the game might be over.
Yeah.
Right. And so it's much higher stakes. And so I think the scale with transactional semantics, right? Like that's actually the challenge that you're not going to see unless you sort of like work for a payment processor or something like that.
Yeah, I guess that real world pressure challenge, like you are losing money. I'm starting to understand why. Like I have noticed that startups love to hire from certain companies. Startups love to hire from other startups because it's similar environment. From large tech companies, it's a bit of a maybe. I'm generalizing, obviously. Will not be true 100% of the time. But for example, hiring from Google, a lot of startups are not as happy because the people coming from Google are used to having this amazing team around them, internal tools. But most startups love hiring from Amazon. And I'm starting to get a sense of why this actually is.
Yeah, I think that's part of the culture. You get hired as a software developer, and they hand you a pager. And before phone apps and things like that, it was like this pager from the 90s. And it's really great because you have to like operate the software that you write. And if you actually you cannot write the software, hand it over to the testing team, and then throw it over to the SRE team after you're done. Like you own that piece of software.
Yeah, at every team, right?
Mm-hmm.
One interesting thing that we talked about yesterday over dinner with Casey Moratori is you said something interesting on how Amazon measured how on their retail website, I think it was retail, maybe Amazon Prime, the lower the latency of something loading, like a page loading, like a purchase stage or a purchase button loading, the more revenue they got. And they started to measure, and there was a linear correction as the faster it was, the more people converted. And it seemed it had no end. And the question Casey asked is like, okay, if this is the case, what would stop Amazon, because you have the best technologies in the world, you have AWS, you can build whatever you want, to get the latency of the website down to, let's say, like 10 milliseconds or even 1 millisecond? Because if this goes up, you would maximize revenue. So can you tell me about like how that thing, like this measurement actually happened? And why is Amazon's website still maybe not the fastest in the world, even though it would generate so many more billions, right?
Yeah. Well, there are a couple of questions embedded in there, but we'll start with the latency to gross revenue measurement. So essentially, somebody way back when, because we invest in logs and telemetry, started tracking how much gross revenue we would make based off of like the latency for detail pages, based off of latency of gateway, based off of latency of the checkout pages. And they noticed this dynamic where it's like, if you're faster, you just make more money. It's a pretty clear correlation. I think you would even go as far as to say as causation. And so there was this really big focus on latencies. I love the idea that, if you're going to optimize for performance, saying like, why can't we be at 1 millisecond, or why can't we be at 10 milliseconds, and start from there, instead of sort of saying like, hey, let's try to decrease latencies by 50% or 25%. Like, let's just start from what is the conceptually fastest thing that we could do.
Mm-hmm.
And I think in a vacuum, the conceptually fastest thing that we could do is sort of like a monolith, which is how Amazon started,
mm-hmm.
where, you have a web server with all of your catalog information, so all of the items that are there, and then transaction processing on the host. That would be the fastest way to run the retail website.
And basically, like a web request would be, it opens the HTTP or HTTPS handshake, it hits the server in an ideal world has everything cached or calculated, it sends it back, so the total like latency would be the time for this request, the time to transfer that data, based on your internet speed, and that's it. That is the absolute. You cannot be faster than that.
I don't think so. Maybe there's some exotic sort of thing that's
maybe
there.
You can do some exotic protocol that I know predicts the future and like with UDP sends it. But this is your baseline.
I guess the optimal would be like 0-click instead of like a 1-click checkout, right? So it would just send you stuff before like you want it. That would be the theoretical maximum. But if there's some sort of like web request, right? So some HTTP request and then some sort of like buy button, that would be the fastest, right? And that's actually how Amazon was created. We bought this, it was sort of the opposite of horizontal scaling. It was vertical scaling. We bought these big Sun boxes, and, we hacked up our own web server in C++. And, to scale up, we bought bigger hardware. And then when that didn't work, we bought like 6 of these big boxes, and that ran Amazon. And we ran that way up until the early 2000s. And then what we realized, we ran into a wall, which was that, when you built the C++ binary, the binary could only be 4 gigabytes. And that was a hard limit based off of the 32-bit the architecture that we're running on before. We could not get above 4 gigabytes. And so these product managers would come and just be like, well, just make a change for me, right, to the devs. And then they would just be like, I don't think you understand that this is a hard constraint. And so
the size of the code, or the binary code, the compiled one, it was there. And you had so much business logic by then that it just filled that 4 gigabytes.
Yeah. And we had a distributed C++ build. So, you could, it would take many, many hours for it to compile. And so we would distribute it across desktops. And it was this whole big thing. But we ran into that wall. Yep. And so what we decided to do, and I think this was super smart, was like to lean into service-oriented architectures, right? And microservices.
Yep.
And when you break it down, a web service call is essentially, it's a remote procedure call, right? So you have this execution pointer, and then you're like, okay, well, I need to do some computation, or I need to gather some data. I'm going to in turn make a HTTP request downstream to another service, and then you can sort of chain those things together. And so getting back to the original thing about performance, in a world where you have to, because you have thousands and thousands of developers building, this stuff, and the fact that you cannot have a monolith as big as Amazon retail, past something that's sort of like circa 2002 Amazon size, you have to lean into remote procedure call. You have to say that there's a web service. The best performance that you can actually get is always going to be bounded by the number of web requests that you end up making, whether it's the first order calls to say, go get the item details, but then also any blocking call that happens downstream.
And by blocking call, we mean like you need to wait for this to finish to get your data. Like, it's a service that like returns, I don't know, your top 5 most likely to buy things. It might need to make those, let's say, 5 requests or just 1 request. It needs to wait for that before it can return.
Exactly. And you can do this telemetry stuff. You can do this observability stuff to figure out, within that service call chain, what the blocking call is. Yeah. And you can get some amount of visualization on it. And so then you can get down to the point where it's like, okay, if we're going to start from first principles, what's the least amount of latency that you can get for, say, like a web request or a checkout page call? You're going to run into like the absolute minimum, right? And it's going to be based off of like, what are the required operations, evaluation or transactions or whatever for that particular request.
Yeah. And then basically, so as I understand, like as it became a more microservices and services, this was great for maintainability. And also you first just solved the issue of the monolith size. And, as we know, as with history, of course, like now teams could be more autonomous. They're not as dependent. They could build the APIs, but it was a trade-off for latency. And now like you had to go back and figure out the blocking calls, how to speed those up, how to do, I guess, trade-off things like caching. Like, you can have things fast, but it might not be as correct on the first one, or like just tricky UI where you don't show the data just yet, but it's coming and the users sense a sense of like progress, those kind of things.
And it also, I think, forces teams to really, and product to really say, okay, like what is the strictly necessary processing that happens on this page? Some of the work that I was doing before I left Prime Video was basically like you have these really, really big, heavy gateway page, or landing page requests. And, if you're in a situation with high load, can you preemptively reduce the amount of, say, personalization that's going on to sort of speed up that page, or, to increase the amount of like throughput that you're able to have. So to serve more customers, can you do that in a smart way, right? That sort of anticipates load that's coming onto to that page. Mm-hmm. Say if there's a football game coming up or something like that.
Yeah. Well, so it sounds like these are just like they seem just hard to solve, but now you have to solve them. So it sounds like this kept you busy and not everyone else busy at Amazon. And to this date, right? Like, is this? Do you think is this ongoing engineering challenge for Amazon? Because what I would imagine the tricky thing being here is like, okay, you can optimize whatever you have, you can find the critical paths, but Amazon keeps growing, right? Like there's new teams, new services, new everything coming on. So this thing will change all the time. It's an ongoing puzzle to solve.
Yeah, absolutely. Yeah, I think they definitely have a ton of work in front of them. Also, it's part of their ethos to really like launch new lines of businesses really quickly. And so, the ability for a team to go from zero to launch products within the confines and the context of a large corporate entity, I think that's, part of the DNA that's there. So as long as they're planting seeds, as the sort of like internal terminology is, I think that, software developers will be in demand for quite an amount of time.
Yeah, and I guess it's a good reminder that, there's every now and then we have the monolith versus microservices debate that it sounds it kind of just makes sense for a startup to start with a monolith. Like you can always do what Amazon did and you have the benefits of latency, everything is in one place. Like I'm sure there might be reasons to start with microservices to start with, but if you're a small team, like, I mean, even today, I don't think that argument changes, right? Like Amazon got really big wins by starting with a monolith back in the day.
Yeah, absolutely. I think it just makes a ton of sense to start with a monolith, wait till it breaks, and then the part where it breaks is when you have like 50 developers working on the same piece of code. Once that sort of breaking point occurs, then you start to like try to figure out like how you can sort of break things up. But starting with a microservice architecture, especially when you're small, like what a waste of time and energy.
Yeah, totally. So you were a principal engineer at Amazon, and apparently I learned that most companies they have different levels, and again, this principal engineer, some companies have like staff level, but it's usually like entry level, mid level, senior, and then you have staff. Or in the case of Amazon, it's principal. I've learned that Amazon's principal level is both really hard to get into compared to a lot of other companies, and it's pretty special in some ways. So we'll talk about that. But can you tell me like how is the career kind of development? Because most people imagine like, oh, it should be pretty straightforward. I spend like, I don't know, 2 years as a junior, 2 years as a mid roughly, and 2 years as a senior, then I get to principal. How does it actually work at Amazon?
I think it's linear up until you hit principal, right? So, you join, you're a junior developer, you get promoted to mid. At mid, you're starting to influence the team, but then you get to senior, and so now your expected impact is at the team level. And then there's this jump that you get to principal.
And principal it's L6?
Principal is L7.
L7, yes.
Yeah, and so I think you really have to start with like, why is that jump so big? Because I think at pretty much any other company, it's just a linear progression. Like there's nothing necessarily special about staff. You can just sort of go to that level of senior staff and then principal. But for some reason, Amazon decided that they weren't going to have a staff level. Mm-hmm. And so, and I think they sort of like couched it around like having high standards. Basically, to get from senior to principal, you have to do like 2.5 level jump.
From L6 to L7.
Yes.
So technically, it sounds like one level, but at some other companies, this might be like L8, L9, or L8.5.
Yeah. And, so the hand wavy argument is like, hey, we have high standards and like, it means something to get to that level. It's like, fine. But I noticed that some of the best engineers that I'd ever worked with were having such problems getting to principal engineer that they ended up moving to Facebook or to Meta or to all these other places where the progression was just sane. Now
so they're staff or senior staff level.
Now they're senior places. Staff and, principal and distinguished engineer at other companies. Mm-hmm. And so because we had high standards, we actually had this brain drain. And it wasn't a brain drain at lower levels. It was the brain drain at sort of like the higher levels. Mm-hmm. And it's just an example of something where it's just like, why did you do that to yourself? And so that's the context for being a principal at Amazon.
So it's safe to say it's wicked hard to get
internally,
really right?
So I'm colleagues with Ethan Evans. And so we talk about what's the hardest promotion at Amazon. And, I had made the argument that it was senior engineer to principal. And he's like, yeah, that's hard. Actually, the hardest one, Steve, is, VP to senior VP, because there's only 8 spots or 10 spots for that. And maybe 300 VPs that are all trying to get this. That's more of a supply and demand thing. I will say that at Amazon, there is gigantic demand for principal engineers. And so there are roles that have been open for years. I think something on the order of like 13 months or 17 months or something like that to get an external hire to join as a principal engineer. But that metric is only calculated when the role is filled.
Yeah.
And so probably, there are hundreds of principal engineer openings at Amazon. And there are thousands of senior engineers
who desperately want to get
that
there.
would love to be
putting in the work.
And so there's this sort of there's this tension, right? And I don't think you see that at the lower levels. I don't think that that's happening at senior or mid or junior. And so that incongruity, I think, is super interesting.
But once you do get to principal engineer, one thing that I've never heard any other company have is there is apparently a principal engineering community, which is, I've heard, again, from other people that it's tightly knit, it's actually special, it's actually just a really nice organization. Can you talk about that? So once you got in there somehow, I don't know, was it blood, sweat, and tears at promotion?
There is a community. I think it's actually really great. My own history, I went from support engineer to senior engineer in 4 years at Amazon. But then from senior to principal, it took me 8 years. And I got promoted in Q1 of 2020. Turns out to be a consequential year in the industry for the world.
That was forceful remote work started.
And so, I got promoted and everybody's like, congratulations. They used to have a principal engineer offsite where they just flew everybody into Seattle or nearby and then to sort of mingle and to talk to other folks. That stopped during the pandemic. And then, by the time the pandemic restrictions started leaving, the population of principal engineers had essentially doubled. That's still to say, there are still hundreds and hundreds of openings for principal engineer, but then the sort of offsite community shifted over to the senior principals that I didn't have access to. But, at the moment, the manifestation of the principal engineering community is essentially through the Slack channel, which is absolutely awesome. And then we had principal offsites for our local organization, so Amazon Music, Prime Video, Twitch, that sort of thing. Those meetups were amazing. So the reason they were is because of this high standard that Amazon had created. And so what it meant is that everybody that was able to achieve that overly high standard, there's something exceptional about them. They're super deep in a particular technology, or they were associated with, the growth of a really large line of business, either within Amazon or externally. They were essentially leaders within the industry. And you could just scoop out 5 people and then put them into a room, and the conversation is just amazing, right? And I would sort of be like, I don't even belong here. Look at this guy. He wrote a book on a particular topic, and this guy, he was a luminary in a particular field, and then this person just is an amazing code machine and can just write an entire application over a weekend, and then you're like, what am I doing here?
I do wonder if that community might be coming back now. I know you've left, but now Amazon is now in person, because it sounds like a lot of the benefit was the in-person part as well. Because this is what I never heard. Again, even before the pandemic, I didn't hear other companies say, for example, at Uber, I've heard that the senior staff engineers do get together every now and then, but it was very roots. So it was bottoms up. But my understanding at Amazon actually invested not just, some principal engineers saying, hey, let's get together, but also just kind of, making sure that group really had something. I think it's smart. I think more companies should do it, but I'm just not seeing it.
The investment was also in terms of headcount. So there are program managers and product managers essentially that are bringing the folks together.
Oh, awesome!
There's a wonderful series. It's called the Principles of Amazon series, where principal engineers will just they'll do a presentation and it's recorded. That's been happening for 20 years. and we record everything that's there. But it takes work to actually.
But that's an internal series.
Yeah.
And is that open to like everyone at Amazon, or it's for the principals themselves?
Oh, it's open for everybody at Amazon to consume.
Yeah.
And then there might be some senior engineers and stuff like that would make a presentation. That's part of their promotion packet. It was be able to make an Amazon-wide presentation on a particular thing. My point was, though, that stuff doesn't just happen on its own.
Yeah.
Like you have to, you need a program manager or multiple folks to sort of like herd the cats and to like schedule the offsites and to make sure that the Slack channel doesn't go off the rails, right? And it's still useful. And it's just not going to happen like grassroots with just like throwing a bunch of people into a room.
This episode is brought to you by Augment Code. You're a professional software engineer. Vibes will not cut it. Augment Code is the AI assistant built for real engineering teams. It ingests your entire repo, millions of lines, tens of thousands of files, so every suggestion lands in context and keeps you in flow. With Augment's new remote agent, queue up parallel tasks like bug fixes, features, and refactors, close your laptop, and return to ready for review pull requests. Where other tools stall, Augment Code sprints. Augment Code never trains or sells your code, so your team's intellectual property stays yours. And you don't have to switch tooling. Keep using VS Code, JetBrains, Android Studio, or even Vim. Don't hire an AI for vibes. Get the agent that knows you and your code base best. Start your 14-day free trial at augmentcode.com/pragmatic.
I think, these are the things, I mean, we're now exposing a few of these things here and there, but some of these companies like Amazon is a great example where there's more to the eye than what meets the surface. So like once you're inside Amazon, for example, you now, as an engineer, even if not a principal engineer, you now have access to the whole 20 years of principal presentations. Like when I joined Uber, I was amazed at how we had the RFCs available. Like I could read all historic ones. So I think there is, and every company has its own, of course, once you're in there, you have access to this like knowledge base, which it will just never be published. It cannot, because it has, business sensitive things, etc. So I think as an engineer, like you can just really just like be a sponge when you join, especially one of the companies that is known to be a bit more open internally. Even if Amazon, I think a really interesting one, because externally it's very closed, is my sense. They're very careful about what they share. For example, the postmortems for AWS is very few are published externally, but internally they're all there. As I understand, there as an engineer, you can learn from them, like really cool real world learnings.
Absolutely. It is an open place internally, and we're so selective about I say we as though I still work there, but what they publish externally, and the postmortems, we call them COEs. It's
a COE stands for?
It's a correction of error.
Yeah.
It's it's this idea that you have like holes in Swiss cheese, and you have like a failure requires that there's a hole across layers. That's the best reading. Like I would just subscribe to the email list where they were published internally. So you have this like stream of disasters that are going on within the company, and you just you grab some popcorn and you pop open one of these COEs, and you learn so much from that. And I think that's part of the secret sauce. The idea, and I don't know if it's like this for 100% of them, is that it's a blameless culture sort of thing. And so to really screw up requires that multiple people drop the ball.
Yeah.
And you learn so much from that sort of stuff. The brownouts, these lessons that you would learn from, trying to recover from really large dependencies, those things are immortalized inside some of these COEs. So there's some very famous outages that happened within Amazon. And, they were an egg on our face. But we really, really learned those lessons through those postmortems. They're absolutely wonderful.
As a principal engineer, so far we kind of glamorize the role, saying, it is hard to get into, but once you're there, you have the community, you do this really impactful work. But one of the principal engineers at Amazon who's still there, called Bhavik Kothari, he collected some things that are maybe not as glamorous or more challenging about principal engineering. He had 5 of these things, or 5 or 6. I just want to go through with you and your take on them. So first, he wrote, there is this paradox of belonging, that you're part of all teams, yet you're part of none. What does that mean? Yeah, no, so
Bhavik was actually a peer of mine. We worked in Prime Video together.
Oh, awesome.
So he's an awesome dude. Yeah, there are all of these paradoxes, and this paradox of belonging is a really interesting one. you work for the organization, right? You're working cross teams, right? So as a senior engineer, you're embedded on a team, and you own the team's architecture, the operations, the software development lifecycle, and the design. But when you get to that next level where you're working across teams, you kind of operate in this weird layer where you're not on pager duty for a particular team. You have visibility across all of these teams that are there. You're helping to guide and make decisions, but you're literally not on the ground floor anymore. And so, when you work with a particular team, you might call the senior engineers or the mid-level engineers in and be like, hey, let's whiteboard some stuff. Like, let's try to figure out what's going on. You're not on the team. You're kind of this like advisor that's sort of coming in, right? But then, maybe a director or a VP would call you in and say like, hey, what do I own? Like, what's going on? Explain to me this outage, or tell me why we can't build this thing. And then you're trying to whiteboard the architecture and the system, and you're trying to say like, hey, this is what's going on the ground floor. But you weren't part of that team. So you're just sort of operating in this sort of strata where, you don't really belong on a team. I'm an immigrant. I think you are as well. And, my parents came from Asia. I'm not Asian, right? So when I go back to Asia, I'm definitely from the US. And then growing up in this country is just like, I'm not quite an American, right? And so you sort of operate in this sort of, area in the gaps where your identity is really defined by not being squarely in one of these predefined categories. So it's very similar to that as a principal engineer. You're not on the ground floor. You're not checking in. You will check in code, but you're not necessarily part of that team, embedded on that team.
And even if you are for a short time, it's usually a short time. And like tomorrow, the director will call you up and say like, hey, Steve, we need you on this other team. They're in trouble. Move over. Like,
and you parachute in, and then, then they're like, oh, who's this guy? And then your director is like, what's going on? What happened during this outage? Why is the press writing about us? And then you're like, well, here's what's happening on the ground floor, but you're not really embedded on that team.
Which leads us to the next paradox that Bhavik said. He lists a few of the paradoxes, which is a freedom and responsibility. And he writes that you enjoy significant autonomy in being able to choose what you work on. However, there's an implicit expectation and accountability for resounding impact.
Yeah. So, I reported to a VP right before I left the company. And
so they were your manager, basically?
Yeah, my manager was a VP.
Oh, wow. That's... I don't hear many companies having engineers report into VPs.
Yeah.
That doesn't seem very standard.
And so the org that he owned, I considered myself the tech advisor for that organization. It was about 450 people, 450 software developers. And what did our one-on-ones consist of? Right? Like when I would have our one-on-one, it wasn't like, hey, here's, he didn't assign me work. He wasn't like, hey, I need you to build this thing. I need you to design this thing. The context that he set was basically like, here's a direction, right, that you need to go. And the way that you can achieve that type of impact was up to me, right? So he might say something like, hey, availability is so important for, live sports. We just signed, billion-dollar contracts with these sports leagues. And so we need to increase our availability posture. And then I would be like, okay. And then I would go away and it would come back and I would be like, here's what I'm working on, right? Like that type of dynamic, it does not exist at the senior engineer below level, where you're basically telling your boss what's happening.
I was about to say that when you said my manager one-on-ones, he didn't tell me what to do. I'm like, most engineers would be like, sign me up. Like, I don't want, we all hate micromanagement. But now when you're telling me like, he would say like, oh, so we just signed a $1 billion contract. Availability is important. And then stops talking. I'm like, that sounds uncomfortable.
Now,
and basically like you're kind of expected a little bit to like understand what he's expecting, even though he doesn't know. And I'm assuming, there's two ways of going, right? You go back on the next one-on-one and you say something and he's like Steve, like you're a principal engineer. This is not what I expect of you. And you don't want that. Whereas this, if you bring back the right things, so it sounds like you really need to up level and like understanding how like these people think.
Absolutely. And so he's accountable to his boss as well. And, don't get me wrong. I didn't, I owned aspects of availability. There's a multi-thousand person organization at Prime Video doing this stuff, but we owned the live sports aspect of this.
Yeah.
And, there are playback teams, there are, recommendation teams, there's so many different teams that are there that had to really step up and make sure that availability was good. But he would say something like, hey, what is our availability posture for certain aspects? And I would have to go and figure it out.
Yep.
Like, what are we measuring? What are we not measuring? There's a deadline for, the start of a season where we're expecting, millions and millions of concurrent to come in. What can we do between now and then, right? And then if we do write some software, like what is the highest leverage piece of software that we could create that would increase our availability posture? And so the way that I sort of describe it to people is you are assigned not a problem, not even a problem space, you're assigned a direction. You can solve the problem with code, you can solve the problem with system design and architecture, but you could also solve the problem, say, by, I don't know, hey, maybe there's some off-the-shelf software we should purchase.
Yeah.
Maybe there's a dev team that we should start to spin up right now whose job it is to do this particular thing. Maybe we've identified a piece of software and it's already been scoped that this team needs to go and build, but it's not a priority for them. Now we need to go and figure out how we can get them to do it. Can we shuffle around resources, that sort of thing. And so the way I describe it is like there's so many more things on the menu that you can use to solve the problem. And I don't think people recognize that. They think that it's just, when you're a principal, you just code a lot and it's just really complicated.
Or do more meetings. That's what often happens.
I mean, at the end of the day, don't get me wrong. There's a ton of meetings that go on.
Yeah. But this is, I think it's good to like shine light, because I also feel like once it sounds like a big change, but I also kind of feel if you get good at this, you might not really want to go back to having a manager who's like, all right, here's a project, we need to solve, scope it out, and which you can do, right?
Yeah.
That's cool. And now the next challenge that Bhavik said was, this all sounds great, but there's apparently a bandwidth challenge. So it's easy to become this social resource where people just pull you into everything and you're breathing.
Yeah. No, I think I wish I had taken a screenshot, but I have my Outlook calendar, right? So it's my schedule. My day looked like most people's week. So it looked like somebody had just blew up a Tetris factory. There was I would have triple or quadruple booked on a Monday all through the day. So
you would have the manager calendar as an IC.
Yeah. And it's absolutely crazy because, for that large org that I was supporting, everybody just added me as optional, or they might try to say no, you're actually required for all of these meetings. But when you have a triple booked calendar and you're required for this stuff, you just learn that you're going to have to disappoint a lot of people.
Yeah.
And so it's this sort of this thing where it's almost easier to say no now that you're obscenely overbooked versus when you're a senior engineer, you're like, I don't have time to write code, but there's just barely enough time in between the cracks.
Yeah.
And so I think that it's almost like when your schedule breaks, that's when you are finally freed because you know that you can sort of say no to stuff. But ultimately, if I just went to all of the meetings that everybody said that I would have to go to, I would be a professional meeting attender and I would literally have no time to do the work.
And then Bhavik follows up on this next challenge, which is being truly present. And he writes, I think it's almost like, he was sitting next to you. You find yourself physically present in one meeting while your mind is already racing against the next three.
It's a really big challenge. I pride myself on being a good communicator and being present. And when there are 20 things that are going on in the air or 100 things that are going on, it's just really, really difficult to stay single-threaded. And what I ended up having to do is to sort of say okay, I could do all of these things and they would be really impactful, but I just had to aggressively prioritize and say, for the availability, I'm just looking at availability. There's all these other fires that are going on, which is disappointing because there's so many things that, you could be focusing on. It's super difficult. And so I work with a lot of people to try to get them to the next level. And they say, Steve, I'm completely overwhelmed. There are 20 things that are going on. And I tell them Do you think it gets easier? When you get higher level, there's just going to be more and more things on your plate. Why wait until you burn out or you break? You can just start implementing these things now. So every high-level tech I see, I know, and managers included, they have a wonderful system in order to like isolate signal and then cut out the noise. And if you don't have that, you literally won't survive. But it just at the principal level and above, it's just amplified that much more.
I'm getting a sense that a lot of the work as you do as a principal engineer, I mean, there's huge amounts of software engineering, and you need to be, just really good at building resilient systems, learning about new technologies. For example, today, I'm assuming whoever's a principal engineer at Amazon, they're expected to just know everything about LLMs, trade-offs, characteristics, etc. Because they're anyway. But you also need to just do the skills that managers have, which is managing your time, changing context, figuring out how to get that focus time. Like, contrary to popular belief, like managers actually need focus time. So like, I will also always try to carve out some time, but you're now doing it while your title is not manager, but actually it feels like you combine a lot of managerial responsibilities and a lot of, like experienced engineer, and boom, you get the principal engineer role. Oh, the only upside is like, you don't need to do performance reviews for people. Congratulations. You saved a little bit of that
Well,
time.
Actually, during performance review season, they pull the principal engineers in, because if you're stack ranking people, okay, cool. Well, we'll need to take a look at their performance in tech. So I reported to a VP. One of my peers was a director, and he was basically like, "Hey, Steve, I would like you to show up to my performance review for my entire org of 100-something people." And I'm like, I can't do that for you and for everybody else.
Okay, so now it makes sense why, as a principal engineer, your compensation package will be similar to like is it a senior engineering manager or something like that?
Around that,
but basically, like the job has a lot of overlaps. Okay, the benefit is you're not the one delivering the performance review to the direct report, but you're doing almost everything else, or in terms of the effort I'm talking about.
Yeah.
Okay, so having been a principal engineer for 4 years, what are the good things that you really, really liked about Amazon, specifically Amazon's principal engineer role, and what are some of the, not so good or it could have been better things?
I mean, the great parts are you get visibility that you just couldn't possibly have at the team level. Within a large organization like Prime Video or wherever you're at, there are many thousands of people that are working within that organization doing so many things, right? And typically the performance of these people is really high. There's so many different directions that are going on. And so to survive, you kind of have to look inward and you say, okay, well, here's my service boundary. Here's all the software I own. I'm going to own everything within the sphere of ownership. Because you've built this wall up, you tend not to be able to see like that broader picture.
Yeah.
And so as a principal engineer, I think it's really awesome to be able to sort of like spelunk and be able to go to different teams and sort of see that broader picture. And I don't see a way that you would be able to get that type of visibility that's super interesting at a lower level. Mm-hmm. I think the other thing is like, whether it's warranted or not, you do get some amount of status when you go to a meeting. People just listen to you. They listen to your harebrained ideas, and it's kind of nice because you don't necessarily have to like prove yourself over and over again, right?
This is a bit less like professional, like not fights, but just establishing that you know what you're talking about.
Yeah. Now the bad things are, there's a lot of folks that are really good in tech and being really effective as a principal engineer, but then they also, myself included, they're like, okay, cool. Well, that sort of makes me an expert in pretty much everything. And so you would get these principal engineers together. We had a weekly meeting. And so it'd be like, okay, if you wanted to talk about like establishing a constitution for a small island nation, all of a sudden they would just be like, well, like here are the main considerations. It's like nobody has a background in government policy. But all of a sudden, like just because you're sort of trained to do so, you start to like pitch in. You're like, well, actually, maybe we should have 2 branches of government or 3 branches of government. And it just sounds like we would know what we're doing, but we don't. And so there's this trap, and again, I've fallen into it many times, where you actually think you're an expert in one thing, but you're actually not, right? And so, take LLMs. There's a ton of folks that understand AI. I left before it was sort of like allowed to use internally, but I think you can use it now. I'm not an expert in LLMs at all, But I do think that the expectation would be that you understand, how they work. But then the expectation's also like, hey, what should our policy be? How should we be thinking about this stuff? Mm-hmm. And I think that's fine for mature technologies potentially. Like you can ramp yourself up for it. But as like that particular landscape is changing so quickly, I think there's this sort of trap where you speak as an authority, even though you haven't had the requisite time to ramp up on something. Mm-hmm.
And you've been there for 17 years at Amazon. What are your favorite parts of the culture? Like, there's a lot of things that there's the values that we all know, like the frugality, customer obsession. What were the things that you found to be like the most interesting or the ones that had a lasting impact? And how did they change? How did Amazon change over 17 years? They must have changed.
No, I think the things I missed the most in the secret sauce, the leadership principles are good, but I think the actual secret sauce there is principled thinking, right?
Tell me more.
Yeah, so there's invent and simplify and bias for action and all of this stuff, but like ultimately the thing that is amazing about those leadership principles aren't the specific stances that they took. So they decided that customer obsession is a big deal. They decided that bias for action is a big deal. Yep. All of these things. But really, if you looked at a meta level, you'd be like, oh, these guys have principles that they won't budge on. I sort of think about it in terms of math and axioms. Like you just take certain things to be true. Two lines that are parallel, if you extend them out to infinity, won't touch them and won't touch with each other.
Yeah, you assume that's true.
Yeah, you don't prove that. It's an axiom. And then based off of that, you're able to build a system of mathematics, right? And so it's the same thing with the corporate leadership principles at Amazon. They basically said, okay, we are going to fix these things to be true. There are 16 or 12, or I don't know. They just sort of bolted some on.
14 and now they're 16.
And but there are like 4 or 5 that are just really core to Amazon, and we just fixed those things to be true.
Which ones were the ones that you felt were the most present?
Customer obsession. We are absolutely customer obsessed. We'll just burn money to delight a customer. You can be in a meeting with a VP as an intern and you say, hey, that's a bad customer experience. It would be like a needle coming off a record. It would just be like, what are you talking about? Like immediately, right? Bias for action. So like just get some stuff done. Stop asking for permission. Just like go and do it, right? Mm-hmm. Ownership. It's just like you own your software. You run you do the operations. You own the bug count, all of this stuff, right? So those are the ones that are like, those are fixed. And then you start layering things on top of it. And I think it's really great. But, you could take Amazon and you could have like the, evil goatee version of Amazon, which is just sort of the opposite of those things. And that would still be a really valid and awesome company. So you could say, okay, well, what's the opposite of customer obsession? It's not customer obsession or not being customer obsessed.
I think it's, like being about your staff.
Yeah.
Which is Google.
It could be like, hey, we really care about our people above everything else. Or it could be, let's not mince around it. We care about top line or bottom line revenue.
Yeah.
That's totally valid, right? And then you could just fix that. You can't prove that, being, staff focused is a bad thing. You just build that. And then, a certain set of things will happen, like great things are going to happen. And then not so great things are going to happen. Those not great things that happen, you can try to mitigate them, but you can't fix them because you have started with this principled approach to everything.
Yeah. It all goes like everything has.
Yeah.
I see what you mean, but I think what you're saying is like it might be less about what the specific principles are. I mean, Amazon has theirs and we know about them, but it's just sticking to them and not keeping wiggling. Because if you keep wiggling, it's like, what was the point, right? Then you're going to have a really kind of mediocre, truly not standout company, whatever you do.
What does it actually mean to be principled and to not bend when it could be really easy to do so? So that's an amazing secret sauce of Amazon's. People look at the leadership principle and I'm like, no, it's principled thinking. Another thing.
And a lot of this, honestly, from what I understand, talking to you earlier and some other people, a lot of it probably comes from Jeff Bezos being from the top down, being very principled on not saying we will do this, whatever it takes. Sounds like it was customer obsession initially, and then some other things.
Yeah, absolutely. And he was an absolute genius when it came through. So I'm a Jeff Bezos fanboy for sure. Like it just worked. Another thing that that's Amazon's secret sauce is just a writing culture. And so, I spent on the order of like 1 to 4 hours every day reading while I was a principal engineer. And we had a standard format. It was a 6-page memo. And, that would be our business strategy. That would be a system design. That would be, what we call the PR FAQ, so a press release and frequently asked questions for like a new line of business or a new initiative. And everybody was sort of constrained to this 6-page format. And everybody just produces documents in that format for whatever they need to do. And so when I would try to get up to speed on a particular thing, I would just be like, give me your 6-pagers. Give me all your documents. And I just got really, really good at just reading these documents to get up to speed, which was a self-fulfilling and virtuous cycle, which is just like, okay, well, now I need to express myself. And so I will write a 6-pager, and that will set the context for whatever we're working on. We'd go to a meeting, you would read the 6-pager, and it was just super great to just actually just have people do study hall at the beginning part of a meeting where everybody just gets fast forwarded, and then you have a really great discussion at the end. That is what an amazing culture that I think that almost every other company should replicate if they could. But I think the difficulty would be like you actually have to be disciplined and actually have a reading culture, and principled, and have a reading culture, and then actually value writing.
Yeah, I almost wonder if, unless it comes from the top, some of these things might just be really, really hard to do.
Yeah.
One thing that I figured is we're in your studio right now, and you have a lot of these blocks. And I asked them what they are. Are they for promotions or projects or whatever? They're for patents.
Yeah.
And this is for patent number 10,824,964. Can you tell me about why you have these, how they come about?
Yeah.
What you needed to do for them?
So the highest order bit is like, for better or for worse, there are software patents that exist. Amazon, they'll say that basically the reason they have them is defensively because, other people will assert that, hey, you're in violation of our patents or our IP.
Yeah.
And then, we'll use them reactively. Well, okay, fine, but, you're also in violation of these other things.
Yeah.
And so, there is a culture of trying to make sure that, we protect ourselves in that way. But, there's the other part of software patents, which is basically like, hey, can you really patent like math or whatever? And so what I learned over time is that, I'm just a really bad IP lawyer, even though, as a principal engineer, I might cosplay as somebody that really understands software patents, right? At the end of the day, what we would do is we would take our important 6-pagers and we would hand them over to the legal team. And then they would just be like, oh, this stuff is really interesting. Like, let's explore that. And so it turned into this awesome thing where like we just had ready inputs to go into like into that particular system.
A writing culture turns out has a bunch of benefits.
Exactly. And I think that there's this sort of like, the concept is called like the curse of knowledge, which is essentially like if you understand something, you discount how long, how easy that concept is.
Yeah.
And so it's just like, you don't get it, you don't get it, you don't get it. And then you get it. And then you're like, oh, that's trivial. Right. Yeah. Even though, there could have been, it could actually be novel or it could actually be interesting. And so what ends up happening is that you would just throw these documents over to the lawyers and then they would basically be like, oh, this stuff is great. And you would just be like, well, that's just regular software development, or that's just the context and domain that we were living in. It turns out that there's some interesting stuff. This particular patent I'm proud of. So there's a system design interview question that seems to be popular right now, which is like design Ticketmaster. Right. And so I worked on Amazon Tickets and, we ended up shuttering that business, but, we ended up building like one of the world's fastest like ticket selling systems like in the world, right? We could do many, many orders per second. So the use case is basically at T0, that's, for a really big ticket on sale, that's when the maximum amount of demand and requests are coming in. And you want to sell out all of your ticket supply as quickly as possible. The problem is, I think, one where you have seated concerts. And so when you purchase a ticket, most of the time with the system design stuff, it'll be like general admission, or it won't be a high ticket on, like one with a bunch of demand. You have to find contiguous seats.
Yeah, so the ones
really,
that are
really
like
quickly.
Next to each other.
Yes, exactly. And so, it's it's actually really hard. Like, suppose it was a SQL database as your backing store. Like, how do you come up with a SQL query that's just like, hey, give me the best 4 tickets, within this particular price range that are sitting next to each other?
Yeah. Now you're thinking, so this is a real world thing where you want to be as efficient as possible in terms of resource usage. May that be, maybe you want to minimize your CPU or memory, depending on what you have, I assume. And you need to do this as rapidly as possible to give this to people. Okay, so now we're talking about a problem that seems like pretty novel in some ways, right?
Yeah, and so I did this patent with a senior principal. I was a senior engineer at the time, but the idea is like, what is the theoretical maximum speed by which we could, show this inventory to people? And it turns out that, even if you have a high ticket on sale, you only have like thousands of tickets at the end of the day.
Yeah.
So instead of making a request to like a backend that would conduct some sort of search across the space, what if you actually inverted it and then you basically had each of the individual hosts have like some view on the entire arena or venue that was there? And you loaded up all of that availability and inventory into like L2 cache on a CPU.
Yeah.
Because it's actually not that many. So if you had this compact representation...
Yeah, well, caches are pretty big, yeah.
Then what you can do is you can do bit manipulation to like really, really quickly get contiguous seats that are there. And then what you do is you can like send in that particular request and try to like reserve those particular seats.
Yeah, now there's a logging problem.
Which is much more tractable than like, hey, there's 2 million people that have just hit your on sale on this
each
page.
Of them, I'm going to search for each of them.
Yes. So the inversion of that ordering process, by which you like actually send out the inventory to the individual nodes and then like load it up into CPU cache and then just do bit manipulation, and then try to lock that resource from the individual nodes. That was the basis of this particular patent.
Awesome. Oh, that's clever. And like that sounds like some, people are always asking like, oh, on my job, I don't use the algorithm stuff or any of the formal methods. It sounds like there are some uses of it, especially when you're trying to figure out what is it, like when you just taking away from the pattern, like just having a problem like this and saying like, what is the theoretical limit that we can do? What is the fastest possible? Like to answer that, you probably want to have access to these tools, so it's not always the time and effort to actually get into these things. And so what are you up to now that you've left Amazon a year ago after like 17, 18 very long years?
I'm just making content. I'm just sort of living the dream there. Making YouTube videos. Started up a newsletter. I have a Discord community and
and we're going to link all of those below. I actually got to first know you before we started talking. This was probably a few years ago from your YouTube videos, which are, you shared a lot about like Amazon things, software engineering things, and just like your general thinking. But yeah, your newsletter is a new one. So we'll link it in the show notes below. It's always a good way to keep in touch. And also, like on your YouTube channel.
Awesome.
So as closing, I have some rapid questions. Okay. So I'll just ask and you just shoot what comes to mind. What is career advice that greatly helped you in your path?
Yeah, I mean, this is, I talk a lot about this. It's kind of like, oh, what's your favorite food or your favorite movie? It's just like, there's so much there and it's hard to pick one. What I would say is, instead of saying like, hey, what's the technology that I should learn that's really going to, make my career, solid? Instead, sort of flip it around and say like, how can I quickly learn skills? Mm-hmm. That makes you sort of like recession proof, right? That sort of makes you valuable. It's essentially meta learning. It's like, how can I learn something faster and faster? If that's your focus, then you'll always be, you'll never have a problem finding a job and you'll never have a problem progressing in your career. Now, some of the skills may be difficult to find resources online, but I think if you just sort of think about like, what's a valuable skill that if I knew right now would make my, job search easier or would like make me, perform better on the job. And then just sort of thinking about acquiring that skill as quickly as possible.
Mm-hmm. And do it now. Like, don't wait.
Yeah. Well, people tend to postpone themselves. They'll be like, oh, well, I'll start when, everything is lined up. But like to begin, you just need to begin. Like when you start something, that only then will you know what you need to do, instead of saying like, oh, I need to get everything that I need to do first before I start.
You've used a lot of programming languages. Which one's your favorite? And why? And which one you do dislike most?
Yeah,
I'll
I have like obviously there's no perfect programming language. What I would say is like, I really enjoyed Perl, and nobody would ever give that answer. But I just like this concept of like, there's just so many different ways to do it. It's a write-only language. Like you can't read anybody else's Perl. And it's actually one of the languages that like uses up the most power. It's like the least efficient. It's interpreted. Yeah. It's just like terrible.
Also, most of Booking.com still runs on it, or some of it.
Yeah, Amazon's back end was, for a long time, it still might be, sort of like Perl Mason is sort of like web technology bolted onto Perl. But I just kind of like it. I just feel like I can express myself, and there's just however you'd like to express yourself, you can. Mm-hmm. It also looked like an ASCII factory blew up sometimes, and so it's just like it's. Now that it's on a podcast, I wouldn't really, advertise that fact. The best programming languages right now, I think Rust is pretty interesting, so I might, pick that up. At the end of the day, like, I really love the boring languages.
Yeah.
So, Java with, for all of its stuff, like its verbosity, and I think it's just a great language, like a JVM-based language that has essentially like great like library support and a bunch of stuff written for it, but it's just like super boring. Maybe it's just because I'm from Amazon and we do this like enterprise stuff. Like, it's a fine language.
And then I see you have a large bookshelf here. You also read a lot, especially at Amazon, although mostly internal documents. What is a book that you would recommend? Something around software engineering that you enjoyed, and it cannot be that book.
It can't be your book. No. Okay. What I would say is, I just given the advice about meta learning and career growth. I think that most software developers should read a book by Cal Newport. It's called So Good They Can't Ignore You. And so the concept there is around career capital. So like, what are the skills that are in the most demand? And if you can just like learn those skills, then you become in demand. And then, from there you can choose what type of lifestyle that you'd like. You can also like sort of lean into, some of the science of meta learning. So deliberate practice, spaced repetition, that sort of thing. In terms of like tech books, I think the new AI engineering book by Steve Huynh is amazing.
It's
I think DDIA, so the design of data intensive.
It's so good. A new version is coming the end of the year, actually.
Yeah, I'm excited about that. I think that'll be pretty good. But at the end of the day, like, you don't want one book on your bookshelf. You want 50 books on your bookshelf. And so, I think within a particular subgenre of tech books, I'd have recommendations there. But
Steve, this was great.
Awesome.
Really enjoyed it.
Yeah, great. Thanks so much for having me.
Thanks a lot for Steve for sharing all these details. Although Amazon's principal engineering level feels surprisingly difficult to get promoted to, I have yet to hear of such a strong principal engineering community than what Amazon builds and keeps investing in. This community itself could be a reason enough to consider the company after the Principal Plus level, should you have the opportunity to do so. For a deep dive into Amazon's engineering culture, including the details on compensation, career ladders, performance reviews, and engineering processes, check out the Pragmatic Engineer deep dive linked in the show notes below. If you've enjoyed this podcast, please do subscribe on your favorite podcast platform and on YouTube. This helps more people discover the podcast, and a special thank you if you leave a rating. Thanks, and see you in the next one.